The iSAVe is the next generation of skid resistance measuring equipment. The Intelligent Safety Assessment Vehicle, iSAVe, provides a major advancement in measuring skid resistance and interrelated road surface characteristics. The iSAVe has been developed in conjunction with our Swedish partner Sarsis ASFT and working under license to the UK Transport Research Laboratory, TRL. ARRB Systems' new iSAVe is manufactured in full compliance with the current British standard, BS 7941-1 2006. This system is used to measure the continuous wet skid resistance of defined sections of road surface across a network in both wheel paths. This helps ensure that an appropriate level of grip is provided throughout. An emphasis is placed on high-demand locations, such as the approaches to traffic signals and pedestrian crossings, or around tight curves, where vehicles are typically required to brake and accelerate, sometimes in emergency situations. This is the Laser Rut Measurement System, LRMS for short. This is the laser system the iSAVe uses to automatically detect and characterize pavement rutting. 2 LRMS laser units are integrated into the iSAVe. The system uses 2 3D laser profilers that digitize transverse sections of the pavement with 1,280 points. The software interprets distortions to the straight laser line as variations in the transverse surface profile. Each frame is analyzed to determine the presence of rutting on the pavement surface. The LRMS equipment is used to measure a transverse profile in order to determine rut depth and rut characteristics. The processing software allows rutting to be measured using the string line and straight edge models. The flexibility of the Hawkeye software allows reporting of the type, severity, and extent of rutting in a manner that meets the specific needs of the user. ARRB has a strong working relationship with the manufacturer of the 3D sensors and continues to provide them with feedback to increase the functionality of the system. This is the Digital Laser Profiler, DLP for short, which is the non-contact World Bank Class 1 inertial laser profiler, which uses lasers and an accelerometer located in each wheel path to measure the longitudinal profile of the pavement. The roughness data is derived from these measurements. The Hawkeye system measures the macro texture of the pavement surface using 3 non-contact lasers. The 3 lasers are situated in each wheel path and along the center line of the iPave. The macro texture is reported as mean profile depth, MPD. The iSAVe is fitted with several digital imaging cameras, which are used to record digital images of the pavement and road assets. The cameras are oriented to ensure that points of interest are recorded in the camera's field of view. All cameras are located and calibrated for scale measurement, which allows for the position of all visual assets to be referenced geospatially. The toolkit provides full data processing, analysis, and management capabilities on all measured data collected by the Hawkeye 2000 system. The software also allows for full control and synchronization of all raw and processed data streams collected. The core of the iSAVe is the Sideway Force coefficient, SFC, assembly, which measures the friction of the road surface. ARRB Systems' iSAVe is capable of measuring the frictional property of a road network in both wheel paths continuously at traffic speeds, and thus collecting far more data than traditional locked wheel or friction testing equipment, such as a grip tester or other trailer-based continuous friction measuring equipment, CFME device. Sideway's force coefficient is the Sideway Force method of measuring resistance to skidding, as the alternative locked wheel or braking force being less suitable for routine measurements. A freely rotating test wheel, fitted with a standard smooth test tire to eliminate any effects due to the wear of tread patterns, is inclined at a large enough angle, alpha, to the direction of motion of the vehicle, F sub v, to generate sideway force, F sub s, by the pavement tire interface, and to be insensitive to small changes in angle when the vehicle turns. The test wheel is set at a 20-degree angle to the forward movement of the vehicle, with the known load applied downwards. and a controlled flow of water is applied to the surface to provide a 0.5 mm film of water immediately in front of the test wheel. The ratio of the force developed at right angles to the plane of the wheel, the sideway force, to the load on the wheel is the sideways force coefficient. The main advantages of this method of measurement are that a continuous record of resistance to skidding is obtained. The test tire has a reasonably long life, and the system is capable of collecting continuously for up to 300 kilometers of data at a time. Single wheel path testing, due to the low water flow requirements, and a large 12,000-liter water tank. To obtain a sideway force coefficient (SFC) value, the measuring wheel is angled at 20 degrees, with tolerances +1 degree or -0.5 degrees to the line of the iSAVe chassis. To determine the wet skid resistance, the variables measured are the vertical downwards force on the test wheel, nominally 2 kilonewtons or 200 kilograms, and the sideways, horizontal force on the test wheel. The skid resistance parameters derived from the measurements are sideway force coefficient, SFC, which is the ratio of the sideways force to the vertical force, sideway force ratio, SR, which is the SFC multiplied by 100, effectively a percentage. Traction is also reported, which is the sideways force in newtons. To simulate rain on the road, the iSAVe aims to have a 0.5 mm thick and 80 mm wide water film on the road. The water flow is automatically turned on when the measurement wheel is lowered and off when the wheel is raised. The water pump is regulated by a motor controller so that the pump will have the correct flow at all speeds. A temperature sensor measures the water temperature. The tire pressure monitoring system is a self-regulating device which maintains the correct pressure in the test tire. If a puncture occurs, the wheel will go up automatically and measurement is canceled. Using compressed air from the vehicle, air runs through the valves and hoses into the inner tube. Directional valves for inflating and deflating are controlled by the Programmable Logic Controller, PLC. A global positioning satellite, GPS, system provides accurate and synchronized spatial location Hawkeye data against GPS coordinates for export into asset management systems.